We are currently observing an X-class solar flare, the largest we've seen in decades. The resulting coronal mass ejection is heading towards Earth.
A massive sunspot, larger than anything we've seen in decades. It has appeared on the sun's surface, and it's aimed directly at Earth. Astronomers are in a state of panic. This is not just any sunspot. This one has the potential to unleash a solar superstorm powerful enough to cripple our planet. Communications, power grids, and satellites could all be wiped out. The clock is ticking. Could this be the disaster we've been warned about? Brace yourself, because this is no ordinary event. The unprecedented size and power of the sunspot. Astronomers are worried because a big sunspot, one of the biggest seen in a long time, has appeared on the sun's surface. Scientists say this sunspot is supersized, and it's not just a random mark. It's perfectly in line with Earth, and it could send out solar flares that could be very bad. Strong magnetic activity on the sun's surface causes sunspots. They are often the first signs of solar flares and coronal mass ejections, CMEs. Sunspots by themselves aren't dangerous, but the eruptions they cause can have big effects on life on Earth. NASA's Punch mission says that this sunspot is much more active than usual. Punch has given us clearer pictures of solar eruptions that are caused by the strong magnetic fields of sunspots like this one. These eruptions can cause huge solar flares and CMEs. The mission's results show that when solar flares burst from sunspots, they can send huge amounts of radiation across space at the speed of light. This radiation can mess up power grids, GPS signals, and satellite systems on Earth. The fact that this sunspot is so big and in the direct line of sight of Earth makes it even more dangerous. But the real danger is that a CME, a huge burst of solar wind and magnetic fields, could happen. When CMEs hit Earth, they can mess up our planet's magnetosphere and start geomagnetic storms. These storms can cause power grids to have electrical currents, which can make transformers overheat and cause power outages across a large area. The Carrington event of 1859, which was the strongest solar storm ever recorded, is the most famous example of this kind of event. A huge CME hit Earth and messed up telegraph systems, which caused fires in some telegraph offices. If a CME of the same size hit Earth today, the effects would be much worse because we depend on satellites and electrical systems. Scientists are very worried about the recent appearance of this huge sunspot. Live Science says that this sunspot is similar to the one that caused the Carrington event. It is also more concerning because it is at the peak of the sun's solar cycle. The sun goes through a cycle of activity every 11 years, and we are now getting close to the peak of this cycle. Solar activity is at its peak right now, which means that solar flares and CMEs are more likely to happen. Because this sunspot is directly in line with Earth, it is much more likely to let out a strong flare, or CME. The U.S. Geological Survey, USGS, says that a big solar storm could have terrible effects on Earth. A solar superstorm this big could mess up everything from global navigation systems to satellite communication. GPS, which is necessary for everything from flying to doing business, could go down, causing chaos all over the world. But that wasn't the end of the damage. The solar storm's surge of electrical currents could have a big effect on power grids. Depending on how bad the storm is, a widespread blackout could last for weeks or even months. This would have a ripple effect that would affect almost every part of modern life. NASA's recent work on the Punch mission has helped us learn more about how the sun works and how sunspots cause solar flares. The mission has helped scientists get a better idea of how solar activity works and what we can expect when solar activity is at its highest. Researchers are keeping a close eye on this giant sunspot as it gets bigger. They want to know if it will make solar flares that are strong enough to affect Earth. But because solar flares are so unpredictable, it's hard to accurately predict when and how big they will be. This sunspot is also very worrisome because it could start a chain of solar flares. According to Live Science, solar flares can send out bursts of radiation that mess up everything from satellite communication to power grids. Solar flares can mess up radio signals, navigation systems, and even power distribution networks when they hit Earth. Satellites in space are very important for things like GPS navigation and weather forecasting. They could be broken or damaged. If communication satellites were to go down, it would be terrible for global communications and military operations. The real danger of this sunspot will depend on a number of things, such as how strong the solar flares are and whether they come with a CME. A CME that is sent toward Earth could cause geomagnetic storms all over the place. In 2012, a big CME almost hit Earth, which was the last major solar storm of this size. If it had hit, though, the damage would have been terrible. This is why scientists are so worried about the sunspot we are seeing right now. It could be the cause of a solar storm that could do even more damage. We need to get ready for the real threat of a solar superstorm, not just a distant fear. We can keep an eye on the sun's activity to some extent, but we can't fully prepare for the worst-case scenario because solar flares are so unpredictable. This is why scientists and government agencies from all over the world are working together to learn more about space weather and how we can lessen its effects. Solar storms don't happen every day, but when they do, they can be very bad, so we need to be ready. Solar flares and CMEs, the real threat behind sunspots. Sunspots may look like small blemishes on the sun's surface, but the real danger is that they can cause solar flares and coronal mass ejections, CMEs, which are very violent. This sunspot is especially worrying because it can make solar flares and CMEs that are very strong. These things aren't just interesting to scientists, they're real threats that could change life on Earth in big ways. When the magnetic fields in a sunspot suddenly change, solar flares happen. These are very strong bursts of energy. This change releases a lot of radiation that travels at the speed of light and gets to Earth in a matter of minutes. Solar flares can still mess up satellite communications, GPS systems, and even power grids, even though Earth's atmosphere protects us a little bit. NASA says that solar flares that happen near sunspots can change the electromagnetic environment in the upper atmosphere of the Earth. This disruption can mess with radio waves, especially those used for high-frequency communication, which is very important for the aviation and maritime industries. But the CMEs are the most dangerous of the three. A CME is a huge explosion of solar wind and magnetic fields that rises above the sun's surface and spreads out into space. When a CME hits Earth, it interacts with our planet's magnetosphere, which causes geomagnetic storms. These storms can cause strong electric currents to flow through power lines and transformers, which can cause whole electrical grids to fail. Live science says that a strong enough CME could cause power outages that last for days, weeks, or even months. The terrible effects of this kind of event would spread throughout the world economy, affecting everything from transportation to banking. Solar flares can mess up communication and GPS systems, but CMEs can do even more damage to Earth's infrastructure. The last major CME to hit Earth directly was the Carrington event in 1859, which messed up the telegraph system all over the place. If something like this happened today, it would be much worse. Satellites are important for everything, from predicting the weather to talking to people, and a CME hitting directly could take out these systems. The effects on the economy would be huge, and industries like telecommunications, aviation, and energy would be especially at risk. Astronomers are worried that this sunspot size and location could make a CME big enough to cause problems all over the world. The USGS says that a solar superstorm caused by a CME could have bad effects on systems that rely on technology. A CME this big could cause power surges that fry circuits, break transformers, and cause power outages all over the place. Not only would power grids be affected, but the fragile systems that run everything from transportation to military operations could be damaged. The timing of this event is also scary. NASA says that we are now close to the peak of the solar cycle, which is when solar activity is at its highest. During this part of the cycle, sunspots become more common and stronger, which raises the chances of solar flares and CMEs. This huge sunspot, appearing at the height of the solar cycle, could mean that solar activity is about to pick up. People have called this sunspot superside, which means it could make very strong solar flares and CMEs. The fact that it is in line with Earth makes a direct impact even more likely. Scientists have been keeping a close eye on this sunspot because it has already shown signs of more activity. The Punch mission has given us clearer pictures of eruptions from this sunspot, which show how the sun's magnetic fields are getting more and more tangled. The chance of a strong solar flare, or CME, happening goes up as these fields keep twisting and snapping. This sunspot is so big that the energy released in an event like this could be huge, and the effects on Earth could be terrible. The fact that solar flares and CMEs move so quickly is one of the main reasons they are so dangerous. It only takes 8 minutes for solar flares to reach Earth. CMEs, on the other hand, can take 1 to 3 days to get here, depending on their size and speed. The problem is that we don't have much time to respond. Scientists can keep an eye on the sun's activity and guess how likely a solar event is to happen, but there isn't much that can be done to stop the damage once a CME is moving. A big CME heading toward Earth could cause problems right away, with no time for people to get ready or lessen the effects. It's also important to remember that solar storms can have a chain reaction on infrastructure. One solar storm, for example, could damage a satellite, which could then mess up communication systems all over the world. A CME could also cause a power outage that affects everything from banking to medical services. Because we depend on technology for almost everything in our lives, even a short-term problem could have long-lasting effects. Scientists are keeping a close eye on this sunspot's ability to make solar flares and CMEs as they keep studying its behavior. Because it is lined up perfectly with Earth and is big and has a lot of magnetic activity, it is a real threat. The USGS has said that solar superstorms are a sleeping giant that we need to pay attention to. The size of the solar flare, or CME, could cause anything from short-term problems to long-term damage. But the biggest worry is that these things can't be predicted with 100% certainty, and the results could be terrible. The Carrington event and the risk of history repeating itself. The Carrington event of 1859 is one event that comes to mind when we think about how dangerous solar storms could be. It is considered the strongest solar storm ever recorded, and its effects were felt worldwide, even though people didn't rely on technology as much back then. A huge coronal mass ejection, CME, from the Sun hit the magnetosphere of Earth and caused a geomagnetic storm that was stronger than any other. The Carrington event had a significant impact, shutting down telegraph systems worldwide. At the time, telegraphs were the most advanced means of communication. But what would happen if something like that happened today? Scientists are worried because we are now seeing a sunspot that is about the same size and in the same place as the one that came before the Carrington event. Live Science says that this new sunspot could cause a solar storm that is just as destructive. In 1859, people relied on telegraphs, but today we rely on satellite systems, GPS, and power grids. A modern-day solar superstorm would be much more dangerous for the infrastructure we use for communication, navigation, and energy than the systems that were affected in 1859. A CME aimed at Earth caused the Carrington event. It sent a burst of charged particles toward the planet. The geomagnetic storm that followed caused auroras that could be seen as far south as the Caribbean. But more importantly, it messed up telegraph systems. The telegraph wires sometimes caught fire, and the operators were shocked by the electrical surges. This event happened before electrical systems were widely used, but it was still a wake-up call that showed scientists how damaging solar storms could be. Today, if a CME of the same strength hit Earth, the results would be much worse. Technology is essential to modern life, and a solar storm of that size would affect everything from satellite communications to power generation. The U.S. Geological Survey, USGS, has stressed that a solar superstorm like the Carrington event could lead to a disaster on a global scale. if a CME hit Earth with the same force as the one in 1859, it could do a lot of damage to electrical grids, cutting off power to whole areas. The effects wouldn't just last for a few hours or days. A solar superstorm could leave whole continents without power for months. People are more and more worried about how vulnerable modern infrastructure is to solar storms. Solar flare and CMEs release a lot of radiation that can hurt satellites in orbit. These satellites are important for everything from weather forecasting to communication. If a solar storm was strong enough to hurt or destroy satellites, it would cause a lot of problems with communication networks, GPS, and even military operations. A solar superstorm would also be able to damage power grids, which are linked to satellites and need real-time data to work. A CME's electromagnetic pulse, EMP, could cause electrical surges that could damage transformers and cause blackouts that could last for weeks or even longer. NASA's recent results from its Punch mission give us important information about the Sun's activity. They show that the Sun's magnetic fields are becoming less stable and that sunspots like the one currently facing Earth are becoming more active. NASA says that these sunspots are very magnetic and could cause huge solar flares. The worry is that the current sunspot, along with the increased solar activity we're seeing, could cause an eruption like the Carrington event. The magnetic energy that builds up in the sunspot could suddenly release, sending a huge CME toward Earth and causing a lot of damage. The timing of this situation makes it even more scary. The Sun is currently at the peak of its 11-year solar cycle, which is when solar activity is at its highest. During this part of the cycle, sunspots, solar flares, and CMEs are more likely to happen. This makes the chance of a huge solar storm even more likely. The article from Live Science says that solar activity is usually highest at the peak of the solar cycle, which is the phase we are now entering. This sunspot is directly in line with Earth, which makes a strong solar storm even more likely. If the Carrington event happened now, it would have a big impact on the economy and society. A solar superstorm could do a lot of damage to the electronic systems that the world economy relies on. The financial markets would probably be very unhappy because they rely on satellite communications and secure data transfer. If these systems broke down, businesses that rely on GPS and weather forecasts, like shipping, aviation, and farming, would also be in big trouble. Without GPS, planes would be stuck on the ground, ships would get lost, and crops would not be able to be moved correctly. This would lead to food shortages and supply chain issues. The USGS report makes it clear how important it is to be ready for a solar superstorm. Scientists are working to improve forecasting methods and set up early warning systems. Still, it's hard to be completely ready for the worst-case scenario because solar events are so unpredictable. Solar storms can happen at any time, and it can take years to fix the damage they do. The USGS says that businesses and governments need to start protecting important buildings and structures from solar activity. For example, they could build stronger power grids and make it easier to protect satellites from solar radiation. There is a very real chance that a solar storm could happen that is as strong as the Carrington event as the Sun gets more active. The difference between this sunspot and the one that came before the 1859 event is a strong reminder that history can repeat itself. The question is not if a solar superstorm will happen, but when it will happen and if we are ready for the damage it could cause. The Carrington event was a warning, but it could have just been the beginning of something even worse. The current sunspot is getting bigger, and solar activity is getting stronger. This makes the threat of a solar superstorm bigger than ever. People need to take the possible dangers of solar storms seriously and do something to protect our way of life today. The global impact of solar storms on modern infrastructure. One of the scariest things about a solar superstorm is that it could damage modern infrastructure. Telegraph systems were important in 1859, but today, satellites, power grids, GPS systems, and other advanced technologies that need a stable space weather environment are all connected to each other. The sunspot that is currently causing so much worry is in a position that makes it a major threat to all of these systems. It could start a chain reaction of failures that could bring down global infrastructure. Power grids are the most likely to be damaged by a solar superstorm. The U.S. Geological Survey, USGS, says that a big solar storm could cause electrical surges that are strong enough to overload transformers and cut off power to a lot of people. A strong CME, like the one that could happen because of the current sunspot, can cause geomagnetic storms that cause these surges. Power companies might have to shut down the electrical grid to stop these storms from doing even more damage. These blackouts may only be temporary at first, but the effects could last for months or even longer, depending on how bad the storm is. The Live Science article talks about how weak electrical infrastructure is. It says that a solar superstorm could cause a geomagnetic storm that would create an electric current strong enough to damage power transformers. These transformers are necessary for moving electricity, and if they break, it could take months to replace them because they are so hard to make. During such a long recovery time, whole areas could be without power, which would cause important services like medical care, water treatment, and food distribution to stop working. The effects on society would be unimaginable. Whole cities and countries could be thrown into chaos. NASA has also said that solar flares can mess up satellites, which are important for GPS systems, weather forecasting, and communication. Satellites that are in space are especially sensitive to the radiation from solar flares. Solar flares release energetic particles that can break the electronics on satellites, making them useless. If the current sunspot causes a solar storm, it could cause widespread communication blackouts that affect everything from TV broadcasts to international business deals. Satellite-based systems are very important for communication around the world. If these systems stopped working, it would have a huge effect on daily life. The damage to GPS systems would be especially bad. GPS is used for a lot more than just getting around. It's also very important for fields like agriculture, finance, and even national security. Military systems that use GPS for targeting and communication could be hacked, which could make them less effective in battle. In the civilian world, GPS is very important for transportation networks. It is used for everything from air traffic control to coordinating delivery systems. If these systems broke down, it would cause a lot of logistical problems, like planes being grounded, shipments being delayed, and communication between businesses and governments being very difficult. Relying on satellite-based technology is just one part of the problem. The USGS also talks about how a solar superstorm could damage ground-based infrastructure like railroads and pipelines. A CME can cause a geomagnetic storm that makes currents flow through metal structures. This could damage pipelines, railways, and even cables that are buried underground. The solar storm's electromagnetic interference could also mess with the safety systems that keep an eye on these buildings. This could cause big delays in getting goods and services, as well as damage to important infrastructure that is important for the economy. The effect of a solar storm on the financial sector may be one of the most worrying things about it. NASA says that the way global financial systems are linked makes them very vulnerable to space weather events. GPS and satellite communications are very important to the financial industry because they help it do business in real time and keep an eye on markets around the world. If these systems stopped working, the world economy could become very unstable, which would have an effect on everything from the stock market to the value of currencies. Without satellite communication, businesses would also have a hard time getting things done, which could cause a global economic crisis. Damage from a solar superstorm would happen not only right after the event, but also later. Engineers will have to fix power grids, get satellites working again, and rebuild communication networks that were broken. This could take years. Also, the economic effects of such a disaster would be huge, affecting industries that depend on technology, transportation, and communication. Insurance companies would probably have to pay out a lot of money in claims, and governments would have to spend a lot of money on recovery efforts. Solar storms are also unpredictable, which makes the situation even worse. Scientists can see sunspots and keep an eye on solar activity, but it's almost impossible to predict when a solar storm will happen and how strong it will be. The USGS says that even though solar activity is higher right now, we can't accurately predict when or where a solar storm will hit. Because of this lack of information, businesses and governments can't get ready for the worst. There isn't a reliable way to warn people about solar storms, so we might not have much time to react if a big solar flare or CME happens. The current sunspot is directly in line with Earth and the Sun, which is at the peak of its solar cycle. This means that the chances of a solar superstorm are higher. There is a real chance that space weather could cause widespread damage to infrastructure, and it is becoming more and more clear that people need to do something to protect themselves from the dangers it poses. The Punch mission by NASA and the work of other scientific groups have helped people understand the risks, but we still need to do more to get ready. The immediate effects of a solar superstorm may seem far away, but the truth is that the infrastructure we rely on is weak to the sun's whims. The more we depend on technology for things like talking to each other and finding our way, the more likely it is that a solar disaster will happen. Now is the time to get ready before the next solar storm hits and makes us open to nature's unpredictable forces. The economic consequences of a solar superstorm. The intense solar activity we are seeing right now could cause a solar superstorm that would have terrible effects on the economy, much worse than most people think. The most immediate effects would be felt in the power, communication, and transportation sectors, but the effects would spread to almost every other industry. Technology is a big part of the world's economy. If this infrastructure gets damaged, it could have a big effect on the market, affecting everything from money to farming. The power industry would be one of the first to feel the effects. The U.S. Geological Survey, USGS, says that a big coronal mass ejection, CME, aimed at Earth could send strong electric currents through the ground, which would damage power transformers and grids. These grids, which power whole areas, would be very easy to break. A CME could cause electrical surges so strong that transformers could burn out. This could cause blackouts that last for weeks or even months. Power companies would lose a lot of money while the transformers were down because it costs a lot of time and money to fix them. A blackout that affected a lot of people would stop factories from making things, break down communication systems, and slow down important services. The Live Science article goes into more detail about how these power outages could hurt basic services like healthcare, water treatment, and transportation. This would slow down the economy's recovery. The longer the power goes out, the worse the damage to the economy will be. Businesses and factories would shut down, and services that need electricity, like refrigeration, would be affected. For example, supermarkets and supply chains could break down, making it hard to get basic things like food and medicine. Transportation systems, which depend on GPS and satellite communication, would also stop working. If GPS didn't work, not only would flights be cancelled, but logistics networks wouldn't be able to work, which would stop shipments of goods around the world. NASA says that these problems could cause a global supply chain crisis that would make trade and market problems even worse. A solar superstorm would also have an effect on the financial sector. Satellite communications are very important for trading and banking around the world. If a solar flare or CME were strong enough to knock out these systems, the financial markets would go crazy. NASA's Punch mission has shown that the financial industry is very vulnerable to space weather because it relies on satellite-based data. Banks and other financial institutions wouldn't be able to work well without the ability to do transactions in real time or get the most recent financial information. Stock markets could be very unstable, and the value of currencies could change a lot. If investors take their money out of markets that they think are risky, the global economy could go down. A solar superstorm would also have a big effect on farming. The USGS says that solar storms can mess up GPS and satellite communication, which are very important for modern farming. Farmers use satellites to keep an eye on the weather, check on the health of their crops, and control their irrigation systems. If a solar storm messes up these systems, it would be hard for farmers who need accurate, real-time information to know what to do. A big CME would do a lot of damage that would take a lot of work to fix, especially to important things like power grids, satellite systems, and communication networks. According to the USGS, these recovery efforts could take years, and in the meantime, the world's economies would have a hard time getting back on track. It would cost a lot of money for governments to rebuild, and insurance companies would have to pay out a lot of money. The disaster could cost the economy trillions of dollars, and businesses, governments, and people will all have to pay for it. One of the hidden effects on the economy could be the loss of human capital. NASA says that satellite technology is very important for some fields, such as telecommunications, healthcare, and aviation. Businesses that need safe and constant communication could fail if communication satellites stop working. Many hospitals and emergency services use satellite-based communication to work together when there is an emergency. This could cause a lot of problems. A solar superstorm would cost more than just money in terms of lives and health. It would also include the health and lives of people who can't get medical care or other important services. The insurance business would also be hurt a lot. It's hard for businesses to know how much risk they are taking because solar storms are so unpredictable. This makes them more likely to be held liable. Because of this, insurance rates will probably go up as companies try to protect themselves from the risk of a big solar storm. But the insurance industry might not have enough money to pay for such a big disaster, so the costs of recovery will fall on taxpayers and governments instead of the private sector. A solar superstorm could have economic effects that even affect the military's ability to protect the country. Satellites are very important to modern defense systems because they do everything from help with navigation to help with communication. Lastly, we shouldn't forget how a solar storm can affect the environment. NASA says that the damage to power grids and communication systems could make it harder to stop climate change. If there were problems in the energy sector, it would be hard to switch to renewable energy sources and use new technologies to slow down global warming. The money spent on recovery would take focus away from long-term goals for sustainability, which could have a big impact on protecting the environment and future generations. So, the full economic effects of a solar superstorm are much bigger than just the short-term problems with power, communication, and transportation systems. It would cause a lot of problems all over the world that would take years and cost trillions of dollars to fix. It would also have a big effect on the economy of the world. The more we rely on technology for everyday tasks, the more we see how weak modern infrastructure is. Preparing for the inevitable, mitigation, and space weather forecasting. With the huge sunspot, the chance of a solar superstorm happening grows. So the question is, what can we do to get ready for it? We can't stop or change solar storms like we can with many other natural disasters, but we can do things to make the effects of such an event less severe and get better at guessing when a solar storm might happen. For years, space agencies and scientific groups have been trying to find ways to keep our infrastructure safe and make our predictions more accurate. The Punch mission from NASA is very important for helping us learn more about how the sun works. The purpose of this mission is to study the sun's corona, which is its outer atmosphere, and the space weather events that happen because of solar activity, such as solar flares and CMES. Scientists can use Punch to get detailed, real-time information about solar eruptions. This helps them better guess when these dangerous events might happen and how strong they might be. If these predictions are correct, we could have a lot of time to get ready for a solar storm. This would give governments and businesses time to protect themselves. One of the best ways to reduce the damage done by a solar storm is to keep the electrical grids safe. The U.S. Geological Survey, USGS, says that power grids need to be stronger so they can better deal with space weather. CMES make electromagnetic waves that can hurt power grids, so solar storms are really bad for them. These surges can break transformers and other important parts of the grid, which can cause power outages all over the place. Power companies have been working on smart grids that are more flexible and can better handle the shocks that solar storms cause. Predicting space weather is also very important for keeping satellite infrastructure safe. Solar radiation is especially harmful to satellites because it can damage their electronics and make them stop working or fail. Satellites are very important for communication, navigation, and weather forecasting, so protecting them is very important. Scientists are looking into building satellites with stronger shielding that can protect them from the radiation that comes from solar flares and CMEs. NASA has also been working with private companies and space agencies from other countries to make satellite systems that can be quickly turned off or moved to reduce the effects of solar radiation. This would let satellites ride out solar storms without getting hurt for good. The aviation industry is another important part of protecting against space weather. Solar flares can mess up high-frequency radio signals, which pilots and air traffic controllers use to talk to each other, especially on flights that cross the continent. The Live Science article says that these problems could cause communication to break down, which would make flying dangerous. One idea being looked into is to change the routes of flights at higher altitudes during solar storms so they don't fly through the parts of the atmosphere that are most affected by solar radiation. Flight paths could also be changed to reduce the effects of solar flares, making sure that planes can keep flying safely even when the sun is very active. Using solar storm prediction models to protect important infrastructure isn't just a good idea for the energy and aerospace industries. NASA says that we are becoming more and more reliant on technologies that depend on satellite systems. If these systems were to fail, it could have an impact on everything from farming to national security. To that end, governments are also putting money into making predictive models that will help industries get ready for solar storms sooner. These models keep an eye on solar activity and guess when solar flares or CMEs are most likely to happen by using data from solar observatories like NASA's Solar Dynamics Observatory, SDO. Using this information, governments and businesses can take steps to protect infrastructure before a storm hits. Early warning systems are one of the most promising new ways to protect against solar storm. These systems are meant to pick up on changes in the sun's magnetic field and solar wind patterns that happen before solar storms. Scientists can issue warnings about the chance of a solar storm by keeping an eye on these signs. This gives businesses and governments time to take precautions. For instance, power companies could turn off parts of the grid for a short time to keep them from getting damaged, or satellite operators could turn off or move satellites to keep them from being exposed to radiation. Early warnings could also help keep planes safe by changing their routes or altitudes to avoid the worst-hit areas. Because space weather affects the whole world, countries will need to work together to lessen the effects of solar storms. USGS says that space weather doesn't know where it is, and a solar superstorm could hit countries all over the world at the same time. Because of this, it's important for countries to work together to come up with ways to lessen the effects of solar storms. To get the world ready for the solar storms that will happen in the future, space agencies, energy companies, and satellite operators will all need to work together on a global scale. Solar storm prediction and mitigation have come a long way, but the truth is that a lot more needs to be done to prepare for the worst-case scenario. NASA and other experts say that solar storms are one of the most dangerous natural threats to our technology-dependent society because they are so strong and hard to predict. As we learn more about how the sun works and improve our forecasting models, being ready will be the most important thing to do to survive a solar superstorm. We can't ignore the chance that a big solar storm could happen, like the one this sunspot could cause. We can be better ready for future solar storms if we spend money on stronger early warning systems, better infrastructure, and satellite networks that can handle more stress. The role of solar observatories in space weather monitoring. The study of solar activity and its effects on Earth has never been more important. Solar observatories are at the center of our efforts to understand and predict solar storms by keeping an eye on space weather. Scientists can keep an eye on sunspots, solar flares, and coronal mass ejections, CMEs, in real time thanks to solar observatories. These are all important signs of possible solar storm, as worries grow about the current sunspot's ability to start a solar superstorm. The work of solar observatories has never been more important. The Punch mission and NASA's Solar Dynamics Observatory, SDO, are at the forefront of efforts to keep an eye on solar activity. The SDO takes high-resolution pictures of the sun all the time, giving us a close-up look at the sun's outer layers and the magnetic fields that make sunspots. This information is very important because sunspots are not just things we can see. They are areas of strong magnetic activity that can cause solar flares and CMEs. Scientists can learn more about how the sun works and when and where solar flares or CMEs might happen by watching these sunspots in real time. The Punch mission, on the other hand, is looking at the sun's outer corona and the heliosphere, which is the area of space that the sun's wind affects. Punch gives us a better understanding of how solar storms work, which can cause terrible things to happen on Earth. One of the most important things that solar observatories do is give people a heads up about solar storms. Scientists can let us know before a big solar event happens by watching the sun and looking for signs of a solar flare or CME. Businesses in fields like energy, aviation, and satellite communication can benefit greatly from these early warning. Airlines can change the routes of their flights to avoid areas where the radiation from a solar flare or CME is strongest, for example. Power companies can get ready by taking steps to keep the grid and transformers safe. This will make it less likely that there will be power outages all over the place. These early warnings give businesses and governments time to get ready, which lessens the damage caused by a solar storm. We still don't know a lot about how the sun works, but the SDO and Punch solar observatories are doing a great job of watching solar activity. It's hard to guess when solar storms will happen. Scientists know more about the patterns and cycles of solar activity, but they can't always say when or how strong solar flares or CMEs will be. NASA has said that one of the hardest things about predicting space weather is figuring out when and where solar flares will happen. It's hard to tell when sunspots will grow or when they will let out energy as a solar flare or CME because the sun's behavior is complicated and its magnetic fields are always changing. It's hard to predict solar storms, so even though we can keep an eye on the sun and warn people, we can't stop a solar flare or CME once it starts. This is why solar observatories and systems for keeping an eye on space weather are so important. The more information we have about how the sun acts, the better we can figure out what causes solar storms. We can better predict solar activity and give earlier warnings to lessen the effects on Earth thanks to better model. Knowing about the sun's solar cycle is an important part of getting better at making predictions. The sun has an 11-year cycle of activity, with times of high and low activity. Sunspots are more common when the sun is very active, like it is right now, and solar flares and CMEs are more likely to happen. Scientists can guess when solar storms are more likely to happen by studying the solar cycle, but they still don't know exactly when or how strong these storms will be. NASA and other space agencies have been working on improving models that can better predict solar activity. We can better prepare for the dangers of solar storms by getting better at predicting when the sun will be very active. Solar observatories not only predict solar activity, but they also teach the public and policymakers about the risks of solar storms. As space weather events happen more often and with more force, it's important for people to know what the risks are. NASA's Punch mission and other solar observatories are not only collecting data for science, they are also trying to get people to understand how important it is to be ready for space weather. Communities, governments, and businesses will be better able to handle solar storms and keep important infrastructure safe when people learn more about them. As we watch the sun, solar observatories will be more important than ever for giving us real-time information and early warnings. The work these observatories are doing is very important right now because the sunspot is facing Earth and there is a chance of a big solar flare or CME. We can't change how the sun acts, but we can use the information from solar observatories to protect the infrastructure that keeps our world connected and running, and to limit the damage. The unseen risk, impact on human health and space travel. When talking about the dangers of solar storms, people usually focus on technological systems. However, one of the most important but often ignored effects is how they could affect human health. Solar flares and CMEs emit intense radiation. Although Earth's atmosphere protects us, people who live in space or travel at high altitudes are in great danger. As space exploration grows and missions to the Moon, Mars, and beyond become a reality, this worry has become even more important. Space weather has been known to be dangerous for a long time by NASA and other space agencies. They have been working on better ways to protect astronauts from solar radiation, which is stronger in space than it is on the ground. Astronauts on the International Space Station, ISS, could be exposed to dangerous levels of radiation during solar storm. Astronauts are especially at risk for solar radiation when they are outside of Earth's atmosphere. This radiation can cause a wide range of health problems, from acute radiation sickness to long-term risks like cancer. The Punch mission has given scientists important information about solar activity, which has helped them learn more about how the sun works and how solar storms affect people who travel in space. As we get closer to the peak of the solar cycle, the sun's magnetic activity is getting stronger. This means that the chances of a solar flare or CME affecting space missions are higher than ever. NASA has made systems that can predict solar storms. This gives astronauts time to get inside the ISS, where they can be safe from radiation. But the threat goes beyond the ISS. Astronauts will be even more exposed to extreme solar radiation on future missions to the Moon, Mars, and deep space, because they will be far from Earth's atmosphere and magnetosphere. A solar storm that is strong enough could also be dangerous for commercial airlines flying at high altitudes. Solar radiation is especially dangerous for planes flying in the polar regions, where the Earth's magnetic field is weaker. Live science says that during solar storms, planes flying at high altitudes may have to change their routes to avoid the areas with the most radiation. This is because solar flares can mess up communication systems, and being around them for a long time could be bad for the passengers and crew. In rare but serious cases, the higher levels of radiation could cause radiation sickness, especially if a flight is in the path of a very strong solar flare. Solar storms can be bad for more than just astronauts and airline passengers. Solar flares give off radiation that can affect people on the ground, especially those who are high up. But the atmosphere of Earth does a good job of blocking most of the harmful radiation. The real problem comes when solar storms cause a big rise in cosmic rays, which can go deeper into the atmosphere and hurt people on the ground. The effects of these cosmic rays are usually not very strong, but being exposed to high levels of solar radiation for a long time could raise the risk of health problems like cancer or other conditions caused by radiation. One of the most serious long-term health risks of solar storms is that they could cause more people to get cancer because they are exposed to radiation for a long time. Anyone who is exposed to a lot of solar radiation over time could be at a higher risk of getting cancer, just like astronauts are. This is especially worrying for people who want to explore space in the future, since they will be there for long periods of time. The USGS says that the radiation risks of space travel are one of the biggest problems that people who want to explore space face. As space agencies work on long-term missions, like sending people to Mars, they are very worried about the health risks of solar storms. Solar storms can also affect the mental health of astronauts and space travelers, in addition to the physical health risks. Space travel is lonely and confining, and the stress of possible radiation exposure could have serious effects on mental health. NASA knows that astronauts need psychological support, especially on long missions. Solar storms can be dangerous, which adds to the stress for space crews. They need to stay alert and be ready to take cover if a flare or CME happens. Solar storms can be especially bad for the new field of commercial space travel, which is one area of space exploration that is very vulnerable. As private companies like SpaceX and Blue Origin start sending tourists into space, people are becoming more and more worried about the safety of these passengers. Space tourism could put regular people at risk from solar radiation, and the technology we have right now for space travel may not be enough to keep passengers safe from strong solar flares. This means building spacecraft with better shields, systems that can keep an eye on solar activity in real time, and space habitats that can keep people safe from radiation during solar storm. The goal is to make sure that astronauts, tourists in space, and future space pioneers can explore the universe without putting their health at risk. Solar storms don't have as big of an effect on health on Earth right away, but they are still something to watch out for. Solar storms can cause problems with satellite technology that affect everything from navigation to weather forecasting. This can have a chain reaction that affects public health and safety. For instance, GPS failures during a solar storm could slow down emergency response times, making it harder to coordinate rescue efforts during natural disasters or medical emergencies. The stress on power grids and communication systems could also have long-term effects on healthcare infrastructure, especially in rural or underserved areas. The health risks of solar storms are becoming more and more important as we explore space more and more and rely on technology more and more. The good news is that we are working to make space weather, forecasting, and radiation protection better so that these risks are lower. The Punch mission will watch the sun's activity along with other solar observatories. This will give us important information that will help protect people on Earth and in space from the harmful effects of solar radiation. The importance of international cooperation in space weather preparedness. As solar storms become more common and stronger, it is more important than ever for countries around the world to work together to prepare for space weather. Solar flares and coronal mass ejections, CMEs, are dangerous to more than one country or region. They are a global problem that needs a coordinated response from all countries. No country can deal with this threat on its own because solar storms can mess up everything from satellites to power grids. To protect our global infrastructure and lessen the damage that solar storms could cause, governments, space agencies, and the private sector must work together. NASA, the European Space Agency, ESA, and Japan's space agency JAXA are all working together to make space weather forecasting and monitoring better. NASA's Punch mission is one example of a joint project that studies the sun's outer atmosphere and gives scientists real-time data that can help them predict solar storms. The data from these missions is very useful for predicting space weather, and it also shows how important it is for countries to work together. Space weather doesn't care about national borders. An event that hurts satellites in the US could just as easily damage infrastructure in Europe or Asia. International partnerships have been formed in the last few years to deal with the growing threat of space weather. NASA has been working with organizations all over the world to make early warning systems for solar flares and CMEs better. These systems are meant to find solar activity and let governments, businesses, and the public know about it. By sharing information and resources, space agencies can make their predictions more accurate and make sure that countries are better prepared for a solar storm. The U.S. Geological Survey says that a global approach is needed because space weather can affect all of the world's countries at the same time. One of the most important things about working with other countries is sharing information. Using satellites, observatories, and space missions to keep an eye on solar activity and predict solar storms is very important. By putting together data from these sources, countries can get a clearer and more current picture of space weather. Industries like telecommunications, aviation, and energy all rely on satellites and power grids that can be badly affected by solar storms. This information is very important for them. For instance, satellite operators can get early warnings when a CME or solar flare is found. This lets them move satellites so they don't get too much solar radiation. Power companies can also take steps to protect transformers and other important parts of the electrical grid. Preparing for space weather together can also make infrastructure better. Countries can work together to build satellites, communication systems, and power grids that are less likely to be damaged by solar storm. NASA and other groups are working hard to find ways to keep satellites safe from solar radiation. Some of these projects are working on making systems that can detect and respond to solar storms in real time and shields against radiation. By working together, countries can share information and technologies that will help protect important infrastructure from the effects of space weather. Getting ready for space weather is also very important for the business world. SpaceX and other private companies that send satellites into space and explore it are very interested in learning about space weather and keeping their equipment safe. As the commercial space industry grows, people from all over the world will need to work together more and more. Companies and governments need to work together to make new technology that will keep astronauts, satellites, and other space assets safe from solar storms. The article from Live Science talks about how private companies are becoming more and more important in space exploration. This makes it even more important for them to work with space agencies to learn how to better predict and deal with space weather. It's just as important to work with other countries to coordinate response efforts as it is to be technically ready for disasters. It's also a good sign that more people are starting to see space weather as a big national security issue. This shows how important it is for countries to help each other. Governments around the world are starting to realize that space weather, especially solar storms, can pose a direct threat to national security. Military satellites are used for navigation, communication, and spying. If these systems don't work right, it could have big effects on strategy. NASA and the USGS both say that one of the most important things that national defense agencies do is protect these systems from solar radiation. Space weather is no longer just a problem for people who work in space. This is a global security issue because systems are becoming more and more connected around the world. The future of space weather monitoring and prevention technologies. In the future, it will be very important to keep damage to Earth's infrastructure to a minimum by keeping an eye on space weather and making tools to protect against solar storms. Solar storms are becoming more and more dangerous as the world relies more on satellites, power grids, and communication systems. Scientists and engineers are working hard to make new technologies that can predict, lessen, and even protect these systems from the worst effects of solar activity. One of the best things we can do to keep an eye on space weather is to keep building satellite systems that give us real-time information about solar activity. NASA's Punch mission, for instance, will teach us a lot about the sun's outer atmosphere. This is very important for figuring out where solar flares and CMEs come from. Scientists will be able to track solar events with never-before-seen accuracy on this mission and make educated guesses about how they might affect Earth. NASA and other groups can predict when solar eruptions will happen by keeping an eye on solar events like sunspots and the magnetic activity that goes along with them. This gives businesses and governments time to prepare for any issues that may arise. Another area of innovation is making better shielding technologies for satellites and spacecraft, as well as keeping an eye on solar activity. Live Science says that solar flares and CMEs send out radiation that is harmful to satellites. This could break their electronics and stop them from working. Another area of research that looks promising is creating systems for predicting space weather that can better predict solar storm. NASA has come a long way in this field with its Solar Dynamics Observatory, SDO, and other tools for studying space weather. These systems watch the sun's activity in real time, which lets scientists study solar flares, CMEs, and other solar events as they happen. By improving their forecasting models, scientists can make better guesses about when solar storms will happen and how strong they will be. This information can be used to send out warnings in a timely manner and take steps to protect Earth's infrastructure, such as shutting down power grids that are at risk or moving satellites to avoid direct exposure to radiation. One of the most important things to study in the future is how to make early warning systems for solar storms. The USGS has said that it is very important to have a global network of space weather stations that can warn people about solar events before they happen. These early warning systems could help protect important infrastructure like power grids and satellites by telling businesses and governments to get ready for the effects of a solar flare or CME. If a big solar storm is found, these systems could automatically shut down power grids, change flight paths, and tell satellite operators how to keep their systems safe. The better these early warning systems are at telling us about solar storms, the easier it will be for us to deal with the problems they cause. Along with predicting and keeping an eye on solar activity, people are also becoming more interested in making important infrastructure more resistant to solar storms. Solar storms can have a big impact on power grids, especially when a CME hits Earth. It can cause geomagnetic currents that can hurt transformers and other parts of the power grid. The USGS has said that it is very important to make power grids less likely to be affected by these things. One way to fix this is to make grid systems that can change and separate broken parts so that the whole network doesn't go down. Power companies are also thinking about adding surge protectors and other safety devices to keep transformers and other important parts from getting damaged. Space exploration is running into new problems as more people want to go on long trips to the Moon and Mars. Astronauts who go outside of Earth's protective atmosphere will be exposed to more solar radiation, which makes them more likely to get sick. As they plan for human missions to the Moon, Mars, and beyond, NASA and other space agencies are working on ways to protect astronauts from the harmful effects of solar flares and cosmic rays. Some of these technologies are advanced materials that can absorb and deflect radiation, as well as shelter systems that would keep astronauts safe during solar storms. Keeping people healthy while they are in space is one of the most important things that space agencies can do as they push the limits of human exploration. Scientists are also coming up with bigger plans for how to lessen the effects of solar storms in the future. One idea is to put fake magnetic shields around Earth or spacecraft that would stop solar radiation from reaching the planet or astronauts. There is still a lot of research to be done on this idea, but the thought of a man-made shield to protect against solar storms is very exciting. By pushing the solar wind away from Earth and spacecraft, these magnetic shields could protect them from solar flares and CMEs. This would keep both our infrastructure and people who travel to space safe. There are more than just solar storms that can affect the future of technologies that can keep an eye on and stop space weather. For years to come, people will talk about and write about solar storm, not as a warning of certain doom, but as a reminder of how weak our systems are when they aren't ready. The real mistake would be to not learn from what this sunspot has taught us. We may never fully understand how solar storms affect us, but what we do in response is what really matters. It will be hard, but it will help us make better space weather rules and tools in the future. So the question is, will we be ready when the next one comes?